Let's see if I can hear myself properly. Let's see if I can hear myself.
Seems to work fine.
I muted myself again. That wasn't my intention. There we go. There we go. Welcome to DOTS Bots. Unity DOTS-based game development. I'm just gonna make sure I have tweeted out everything. Yes, looks fine. And let's go back to the game. I think it works like it should. If there's any problem, please let me know. And let's do this. So, quick recap. What we managed to do last time was to let me just pull this closer to the microphone. There we go. We managed to do this stuff. So you can see, I don't know if this is clear enough, but we have the selection box here, which I can drag. And you see all the robots underneath the selection are marked red. And this works pretty good. And we did the selection itself and then the marking of the robots via a custom shader or a custom shader graph thing. Hi Skull Sam, welcome back. So we made that, and we also confirmed the performance that in this case the drawing of the 10,000 robots are by far the biggest performance hit. This selection of selecting 10,000 robots takes less than half a millisecond basically. So it's, you know, almost nothing. And we can probably pretty easily continue with this and not bother with optimizing it anymore like that. So what should we do this time? So first of all, I'm just gonna clean up one thing, or two things. I've already cleaned up one thing, and I'm gonna clean up another, and that's this thing, you know, always shows up. And I just wanna, well, maybe it's alright, but no, let me, we need to have like, so when I drag and let go, this box should, you know, disappear, and we should just have the selection left. So first of all, I'm just gonna point out that I made, oh, that was the wrong project. So before I had these two start point and end point vector that indicated the selection, and I just pushed them into this selection job and use this if statement to know if they are inside. And somebody rightfully pointed out that it's much better to use a rect, and yeah, of course it is much better to use a rect, much better. So I switched to a rect, select rect. So it's first of all, it just makes sure we are in the right space with the units, and then it puts that inside of a rect, and then we use this rect with this contains instead of using this if statement. So we can just remove these two. That's good. Whiskey, obviously, I need to, that's sort of a given now that I drink something nice when I stream. That's my treat to myself for streaming. Because, you know, it's way more exhausting to stream than I thought, but it's fun as well, you know. It's just takes a lot of energy. Anyway, so I want to make sure that the drag box disappears when I let go of the mouse, and that's very easy. However, I realized there's one thing that I want to import into the project that I always have in every project, that will probably then people might have not seen before, because it's not that common in my experience. So if we create a folder here and utilities, name that utilities, and then we make, I usually call this just a class named Unity Help, and it, you know, just it's a common thing you do in Unity, and make sure you have that collected in one place, and it should be a public static class. And there's one thing here, and I'm gonna just copy it from my other project. So Unity utility, probably I've renamed it here. Anyway, these functions right here, and I'm just gonna copy and paste all of them more or less inside. And I'm gonna explain what they do and why it's a good thing to have these. And let's include, oh, my bad. Let's include the Unity engine. So what this is, that it's set active. So, you know, the normal set active on a game object, but filtered so you don't set a game object that's already active to active. And so the thing is that this, I don't know if this is really an issue still, but I remember I worked on a game called Battle Right, and we pushed a lot of UI elements and said like they are supposed to be true, and we set that to true every frame, and there was some part of the Unity engine which sort of resetted some variables in the background when you pushed it to be true every frame, even though it already was true. So we had this thing where we make sure that if it's already true, we don't set it to true again. Let me just mute my phone here. And that was something that I've just taken from that, and I always use that if I know there's something I'm going to push true or false potentially every frame. So I do that. And if somebody want to fill me in, or they recognize this, or they may be like, I'm certain this is unnecessary or something like that, please let me know, because this is one of those cases where, you know, there's a lot of stuff happening in Unity. This might be just related to UI stuff. Or the specific thing back in 2015 and 16 when we built Battle Right that was in that version of Unity, and that this might not be relevant anymore. But it's, I think there's a big time investment for me to know that, you know, I need to research it, and I'm just lazy, so I just use this set active all the time. So anyway, so now we have set active. We can do like this, set active, and we just put in this transform the square. That's the visual square on the screen that we are dragging, and we say it's only supposed to be active when we are dragging. So, you know, it's pretty straightforward, you know, set true or false on this game object, and we just use this dragging ball straight up, and that should make it possible to then my old colleague is actually answering, Fredrik Haraldsson. We're still doing it as well, the making sure we don't push through to game object every frame. Haven't researched it if it's been improved though. Yeah, so even Stanlock Studios, which is, you know, a big studio with, or semi-big studio with like over 30 employees, I don't know really anymore, but where I used to work, they are still doing it, so obviously there's some merits to it, even though some might need some research. Anyway, just needed to save that. So now the result should be that everything is selected as long as I keep the mouse button down, and then when I release it, everything should be deselected. But the square should disappear. No, oh, it's still selected. So that means that we are actually saving the selected thing. Or probably the shader. Yeah, this it's probably just saved inside of the let's see here, unit, the selected component data. So remember, we are every time this selected to see if we are inside the screen, the square, the selection square, we push this selected boolean to this material property component, and there's a whole explanation of on the last one how this works with material properties. This is pushed straight to the custom shader or the shader graph, but this one is probably the only thing that is like keeping the information about the selection still. And we could use this, but I think it's more clean to have it like to actually have something that says like, yeah, we are selected in the actual unit data. So we're gonna have a duplicate of this information, but this is really just for the rendering. So we're gonna make a selected just to make it easier for us, and it's, you know, it's not a big deal. And we're gonna push this this data every frame in any case. Unit data in, and let's oh, so now we should actually do something like this where we so we are getting all of the, we are iterating through all of the units. We are checking them if they're inside, and we are pushing the result if they are selected into this thing. But we should probably move out, so we are pushing that information into the unit itself, and that selected boolean inside of the unit is actually driving this one in the end. So that could be done by doing something like this, where we, instead of pushing straight to the material property, we switch this component over to a ref. And that means that we will have access to it, and we can do whatever we want with the value inside, which means that we can do straight up like this, right? And we can swap these out. Indication, yeah, and this should probably, is probably not needed. This list of all of the different positions and everything, selected entity screen point, I don't know if we're gonna need it. We're gonna keep it because there's no, why not to keep it? It's more or less just pushing out the result, which we already have inside of the unit data right now. But anyway, so now we just push it to the selected inside of the unit data component. So now we need to, if we go back to this now, we are just gonna have, they're not gonna show that they are selected anymore, because we don't push it to the material property anymore. So just to fix that, and this is a good, like, how you can like transfer data from one point to another in the in DOTS is, it's actually pretty easy in this case. So yeah, I'm gonna write this. I don't know if this is the right way to do it generally, because it's a little bit weird actually. But I'm gonna explain to you guys why I don't know if I should do it like this. But you're probably gonna agree with me that it's hard to know before we have more material, before we have more gameplay in place. Props like that. So here we have straight up schedule parallel. We can do that, just, it doesn't really matter right now, it's such a small game. So what we can do is like, if data selected is true, then we says material property dot selected equals to 1, else set it to equals to 0. So here we have a situation where, you know, in the initialization part of the unit dots, we figure out who is selected, and we push that to a boolean inside of the unit data. And then in the simulation system group later in the same frame, when this job is over or completed, we do another job, which basically just pushes the selected value into the material property. And we can easily do this stuff up here, super easy, because it's the same entity. The thing is that it's like, in this case, it's cleaner. And no, it's not cleaner. It's just like shows you how you can shuffle things around. And the purpose of this would be like, if you have something else than the actual like on-screen. Let me say. So if you have, you know, you can select everything you want with the selection box like normal, like in every RTS like ever. But maybe you have a situation where you want to like double click on a specific unit type, and you want to have all the unit types selected with it. Then we can push this selected boolean from some other clip, from some other script maybe, and that selected will then push this. So it becomes like a case where selected doesn't have to be pushed by just this thing, more or less. That would be my sort of way of explaining it, but we'll see. We probably don't want to do this selection anyway when we are not, because right now we will have this, it will work, although now when we let go of the mouse cursor, it will deselect everybody, I think. Oh, it's actually not working. Let me see here what I'm doing wrong here. That should work. I'm not really sure what's going on here. If anybody can see the problem, tell me. I'm just gonna try by pushing this value straight here and see if that makes any difference. Because, you know, it's... And if we then, like I said, remove this and go back, we should have it. And any question about anything dots related, just shoot at me. I don't know. That was a weird expression. And I will try to answer it. Last time we had a good question about how, if dialogue system is reasonable to make in dots. So, okay, we have nothing. This apparently doesn't work anymore. So we have destroyed our previous thing. This is interesting. I'm not really sure what I did wrong here. Oh, right. I think I know. Yeah. This is, yes. Once again, a good learning opportunity right here. So, the reason why we don't see anything right now, that's because when you're working with ECS like this, you have something called the entity query, the filter in which you filter everything with, right? So everything that runs through this needs to have the material property, the unit data, and local to world. And the thing is that the material property, that is not on our main game object or main entity. Because if we look at the unit setup code, we can see here that we have something else. We have a game object referring to some other game objects that is underneath the prefab, the main prefab. And that game object, that converts into an entity, and that entity gets this material. So that means that the main unit has the unit data, but its sub-entity has the material property, which makes this thing not get anything, because there's no entity in the whole system which contains both of these. So this doesn't run anything anymore. If we remove this, this will work, and this should work exactly like we expect. But now we have the same problem over here, that there's still no entity which owns both the unit data object and the material property object. So what we need to do is we need to remove this, and instead of pushing it via directly to the normal directly to the component, we need to push it to the component via a command buffer, because we don't have access to that entity when we're iterating on the unit entity. There's separate entity types. So if we back off a little bit here, I'm gonna quote unquote time travel in my code here to get a line of code that I know I've written before. If I press something right now, I'm gonna lose all my history, so let's hope I don't press anything wrong. There we go. So this, I'm copying this line, and I'm fast forwarding back again into whatever I had before. So now we can do like this. We can just steal this stuff right here. And that should more or less be the proper way. So now let's do this to a run, so it's a little bit easier to grasp what's going on here. New entity command buffer, and then we put in a temp object, and then we, just to make sure we don't forget it, we play it back on our entity manager. So we apply our changes, entity manager, and then we dispose of it. And like this can be done inside of a disposable, or using, using something up, and then you have it indented one inside of not the brackets, but the other this. So if you know how to do a using in C#, you can do it with this entity command buffer. But I don't like a lot of indentation, so I just manually dispose it instead. Anyway, now if we do like this and we make this float, let's float like this. Maybe it's more cleaner to look at it. And then we need this, both of these. That should be. So what's happening here is that set component data. Oh, we don't need that. Never mind. What's happening here now is that we're setting this selected parallel first of all on the main unit, and then we are in the next part of the frame. We're iterating through all of these main units, the primary entity of the unit, and then we are looking, is it selected? Then we are pushing this 0 or 1 straight into this component, which is, you know, not on the main. It's not on this entity. It's on this entity, which the unit owns, but it's like a sub component of it. So this should probably work. Let's hope. And there's a bunch of optimizations we can do to that, but it should probably work. There we go. And now if I let go, it still stays. That's interesting. I'm still confused why it stays, because we should rewrite it to be non-selected, and then it should be. So let's just check out the actual values. So if we go to Analyzer and Entity Debugger, we can take a look at one of the random guys here. Let's make sure we don't need to maximize anything here. So here we have the, let's see here. Here we have the unit data. So some random entity here has the unit data and it's selected. Let's see if we can select everybody, more or less, so we can find somebody who is selected and see why they stay selected. Okay, so they stay selected. You can see here that I have some random guy selected here, and the guy is selected in the background by my drag box, and the selected boolean here is checked. So that means that I just need to read my code and understand why I'm oh, right, because this select rect is still pulling the data from the selection, which just is the only reason it's just invisible. It's still the same size. It's just invisible. It's just deactivated, but it's still got the same transform values. So that's why we see. So if we do something like this, let's pull this dragging into a public get private set like that, and we can rename it to there we go. Rename it to just dragging without the underscore, and now we should be able to do like this. You're gonna understand in a minute. So variable selecting dragging, or maybe we can just name it dragging like that. So now we know if we are actually dragging it and if it's visible. This is, you know, the same variable that we are using to make it visible or not. So if we take this boolean and we make it so that if we are dragging and it's on inside of the selection, then it should be show. So now it should just stop being selected when we let go. But and I'm gonna modify it once more, because this is not the end thing we are looking for. But we are looking for just making sure that we understand why the data is. There we go. So now it's deselecting it because we're not dragging anymore. So, but what we can do here is that we can just push this thing, just make it so the whole damn job is only being done when we are actually dragging. you know. Or maybe, you know what, we should probably not do it exactly like that, because we might want to have the resulting positions and all that stuff. The screen position might be a fun thing to use for something else later, and like fun thing, it's not like we need to do something with it, but I've already written the code to extract the screen position from all of them, so why remove it? So so it's just that the selected thing should be like this, so we should not overwrite the selected variable if we are not dragging. That's basically it. So now we have the now the code works like it's supposed to do. If you want to be able to drag and then let go and have it still there. So now it's for the right reasons. Anyway, I think we still can't drag backwards and stuff, but I don't really care about that because it's not really relevant to that's just like obvious quality of life feature. Not quality of life is supposed to be that, obviously, but it's just a bunch of if statement to flip around the rect in some situations, and that's just unnecessary to do on stream. And one day I will take the time and do it on my own time, so and then have it ready for the next stream. But right now we're just dragging from the left to the right up. So now we're going into the Boyd system, and please share your thoughts if anybody here have an idea of how they should move, because I've thought about this and like how do we want to move these guys? So because maybe we shouldn't have like 10,000 of them right now. Maybe we can have like 100 just to make it a little bit more easy to so they don't walk on top of each other all the time. So if we do like this, how do we like right click here and make them move there, and how should they move? Because from my point of view, like moving in like a troop, in a battalion or whatever, like normal RTS game, that kind of programming is quite new to me. I've never done it, and I don't think it will probably take a lot of time, and it's not the type of thing that I want to focus on with this DOTS stream series. So that's why I want to introduce Boyd's, the school of fish type of movement. And I've thought about this, and I realized that it's probably not going to be completely Boyd's system. It's probably going to be a subset of Boyd's system. But we need to make them so they can appreciate each other's and proximity-wise avoid each other, right? That's sort of the point, I think, to start with, or the point, the fundamental thing that we need to fix. They shouldn't walk on top of each other, and we shouldn't use the physics system to do that. We should just make them so they like know about each other and like avoid each other properly, and not just colliding each other and then like go and squeeze against each other, because that's ugly and that's just bad practice, I think. So let's make spatialized avoidance with spatialized fragmentation. So that means that we wanna divide the whole playing field into boxes, and once you're a unit inside of the world, you should like declare yourself as one of these inside one of these boxes, and then when you are looking in the next part of the frame, you might be okay. Who am I close to? Who do I need to avoid? Then you can just check your box and a few others around you. And that will let you know, like, oh, this is, I'm close to somebody else without having to check for everybody on the other side. So that's something that isn't really dots, but it's still like, it will entail a lot of different data structures that you need to know to be able to handle dots. This is super important, and I don't know how far we're gonna get to on this one, but I will try to see how far I can get. And I think for somebody who have never programmed spatialized fragmented stuff, this is pretty interesting, I think, and probably yeah, for me it was really interesting first time I learned. So I'm just gonna go to my other project because I'm gonna steal some code from that. So I have spatialized helper, something no, that was the wrong, that was the meta file. Spatialized helper like that. So here we have something called position to cell and cell index to position. So if we, and we're just going to use the 2-dimensional one. So first of all, we can just create a new file in our project on the utilities and name that spatial helper, and you know, get rid of these type of things, public static like that. And let's go back here and let's copy in these two float 2 or vector 2 versions of it, and import a few things and then see what's missing. Maybe not so much. No, nothing is missing. So first of all, we can get rid of this. These are aggressive inlinings. They basically try to tell the compiler to like copy this code and put it in instead of the function call itself. And but it's not really, it might confuse people, and some people say like the C# compiler will do it for you in proper, and especially with the burst compiler, that the burst compiler might not even care about this, and it's totally unnecessary to put them in. Anyway, so what this means is that we have a situation where we can say like, okay, we have a position and we know how big the whole space is in terms of the boxes. So there might be 10 by 10 boxes, and all of the boxes are 10 by 10 units wide and high or whatever. And with that premise, what box am I in? What index? What's the number of the box that I'm in? So just to point that out, there will be something like this, and I'm not going to spend a ton of time explaining this, but I'm just going to just show a little bit thing. Something here that can visualize this. 2, 3, 4, 5, 6, 7, 8, 9. Perfect handwriting, won't you say? So basically, it's like if I am somebody, a unit, and I'm like here, it should give 5 back, right? And if I'm here, it should give 9 back, obviously. Pretty self-explanatory, and it goes both ways. So if you say like, oh, I'm in box 5, you should be able to put that in here, and it should give you back like the midpoint of the 5 so you can like do it both ways. That's super important. So let's go with that. So the first thing we should probably do is like try to, like, when they are placed on the map, they will like be on top of each other maybe, and we can make it so they like will find the closest one, and like, or the closest ones, and several of them maybe, and try to move away from them and see how that goes, because that's going to be like you spawn and then everybody's going to be like trying to move away in some way, and like properly space themselves, right? So unit data, let's start with a float, proximity distance, and yeah, that should be enough of that, and we can just push this guy up here, and then do a oops, and then declare him. So you know, we have the normal game object in the inspector with the normal float, and then we put it over to the ECS component. So now we have a proximity that we can use to see if we are close enough or something. And then we have the selection UI, and no, let's make that in another place here. We could put this in the same place here, but let's divide it up. So let's make a movement unit movement system base like that, and we implement the update function. So now we have a system which will run whenever something that it handles will be in existence. So let's see. I think we can keep it like this. So that means that if I write entities dot for each, and then I put in this unit data like this. This is quite interesting. It's pretty hidden to me, actually, in schedule parallel. It's pretty hidden, I think, and it annoys me a little bit. But like this system now, this will run when there exists something that owns a unit data, and like it will automatically turn itself on and off based on if something has a unit data that is in existence and is enabled. That confused me in the beginning because I didn't realize why stuff were running or not running. And you can do something like update, always update system. I don't know if that really does more something to the system base. I think so, but I think this should be like, even if there's no unit data inside of it existing on any active entity, it will run anyway. But anyway, we don't need that. We just want to run this system when we have units in the scene, right? And so first of all, we probably want to do this in the initialization phase of the frame. So update in group, and I'm gonna explain why. Initialization system group, like that, because we want to produce the buckets. So let's call them the buckets because that's a good name, it's distinct enough. So all of these, let's call them buckets. We want to produce them, or so we have a whole bunch of buckets with lists inside of them that says like, this is the entities who are inside of me, like that. So let's do something like a variable spatial cells. This is the buckets. Maybe we should just buckets. Buckets. There we go. It didn't look right to me. Anyway, English is not my native language, so sometimes my brain just doesn't work like it's supposed to. Native multi hash map. That's the key here. And we should have a value that is just an integer. We can even put an u in here because there's not going to be such thing as a negative index. And then it's supposed to be an entity, right? Oh, wait a minute. I'm forgetting how you set this up. Oh, never mind. New. This should be right. Yeah, capacity. And the capacity should be as many units as we have. And let's calculate that pretty fast here. So private entity query, unit query, like that. And then override something called onCreate. And then Unity has this nifty thing called get entity query. And we can put in component. I learned it from Frederick earlier a few days ago. Component data. I think data. Isn't that the case? No, probably. Component, something component. Component type. There we go. And then we say read only. And I'm going to explain exactly what this means in 1 second. Like that. So this is more or less a way to say same thing as type of. So if I remove that and make it unit data, that's the same thing. However, because this basically means like we have a query that says like, oh, this query is just gonna grab stuff that owns the unit data, right? However, this way of writing it that I learned from Frederick allows you to do something like this, where you can say exclude, and you can have something else like local to world, like that. And this means like it will make a query that will include stuff that owns the unit data, but exclude stuff that, but only if it also doesn't include the local to world data. And this component type, read only and exclude and stuff, there's other stuff here like write and stuff. This allows us to do this thing where we include and exclude stuff in the query in a one-liner with, you know, the just params, just like however many you want to put in there. Otherwise it's a little bit more syntax heavy. So this way we can just do like this, and for me I use this right now because I want to transfer over to using this always, because it's much more flexible. Anyway, now we can do variable unit count, and we can say calculate entity count, and that means basically we check how many unit data is in the scene, and this allows us to initialize these buckets with that many. Oh, wait a minute. This is referring to when we make this native multi-hash map, we are actually want to have the capacity of this native hash map, of the capacity. It's actually how many buckets we have, not how many entities we can put inside, I think. Somebody correct me if I'm wrong there, but I believe that's the case. So we should calculate how many units, not how many units, how big our map is and how big all of the buckets will be, so we then can know how many buckets we will have. So let's do something like that, where we maybe we can just put in some hard values for now, just because it's easy. So private const int, and we can make it let's make it the size of it int2, we include mathematics, and then we can have map size, and do something like this. Oh, type integer 2 cannot be constant. That was something new. Anyway, it doesn't really matter. And let's say the map is 100 times 100 buckets. So not meters or anything like that, buckets. And then say like int float bucket size. And every bucket should be, let's say, 2 meters wide. I don't know. This is something that you can experiment a lot with this and see which sizes gives more or less performance, because you can obviously like say like each bucket is 20 meters wide or 20 units wide, and then say we have a lot less buckets, and it will be the same area that this grid will cover. But it's all about how the memory will line up with everything and how much will fit into your cache and stuff like that. But that level of optimization is, you know, nobody cares about that if you're a lone Unity developer. But just so people understand what I'm doing. So now we can calculate exactly how many this will be. Unit count, we can keep unit count, maybe we need to use it, and then bucket count. Private static read only. Yeah, you're right. Yeah, private static read only is a good. Private. Well, really, we just need to put it read only here because we don't really need it static to begin with. So bucket count will be x times y. So this is just like, you know, the square. That's it. And then we put the bucket count inside, and then we make it temp job, because we're just gonna use this one run frame, right? And now the fun part starts. So now we can do something like this. Variable bucket index, and we may call on the spatial helper, and we take position to cell index, and then we need the local to world trans, and we can variable position 2D new float 2. So we convert their position to just their flat position, and I'm sure you can get away with this syntax wise in a more clever and good looking way, but this is, you know, it's verbose and nice for people who are not that into the syntax sugar of DOTS and C#. And then we say the space size, which is, you know, the map size, how many buckets we have, how big each bucket is, and then the global offset. And this basically means that if you are not centered around the center point of the map, then you can like have the whole bucket set moved over globally in the world. But this, you know, can be just default, or yeah, just default. That means 0, 0. More, it just generates the default float 2 variable here, which will be 0, 0. So we are on the middle of the map. So now we have the bucket index, and we will have, I think we will have 10,000 buckets, right? Yeah, that should be fine. So what we can do now is we can take that bucket index, add ourselves to this bucket, entity, like this. And the nice thing with native multi-hash map is that the nice thing, the whole purpose with multi-hash map, is that each of these entries in this dictionary, because it's more or less a dictionary, right? Normal C# dictionary. Well, it's conceptually anyway. Each of the elements in, or the keys inside of the dictionary doesn't just have one value. This automatically will create a list of entities for each key, or for each element, which means that we can have more than one entity in one bucket. And that's really important, obviously, because we might have a bucket. Obviously, characters will be able to be in this close enough to be able to be in the same bucket at the same time. So now we know that, okay, this bucket will contain all of them, all the buckets, and all of the guys inside of that specific bucket. That's more or less it. So now we have the spatialized data. Now let's use it. Translation component. Oh yeah, good almost catch, but it's not exactly correct, because translation is the same thing as local position. Our units are, you know, in the root, they don't have a parent, so the parent is 0, 0, so their local position will be their global position, more or less. But local to world is the final transformation of their whole positioning system. So it's better to use that. If we ever put the units inside of some sort of parent, then we need to use local to world if that parent is not on 0, 0, 0. So that's why I use the local to world. Yeah. Okay, so now we should consume this, but we are in scheduled parallel, which means that we can't consume or use the buckets straight after here, because this stuff is not executed until later. This is executed in where it's supposed to be, more or less, in terms of when the data is available. Let me just do one small thing here. So working on void movement. Next up, let's just have it like that. People will understand that void movement is a big thing. I don't really know what we're gonna do after this.
but void movements, this is the stuff right now. So let's make another class. And I think we should just, I'm gonna rename this. I'm just gonna make it so we have this right here. But this is not really unit movement anymore, because it's more or less movement preparation, unit movement prep system. Because this data that we produce, the buckets, it's like prepping work for the actual movement later. So and now I'm gonna do this little funny thing where you do world.get or create, and we get the other system, and then I set bucket set bucket buffer or something like that, and let's send in buckets. And this is something I use all the time. Obviously this method doesn't exist inside of this system, but you can just write it, put in everything you're gonna put in there, and then control dot, and then generate the function. And then I swap over this to public because I like everything public. So now I didn't have to write all of this. C# and Visual Studio have some trick up its sleeve. Anyway, we're gonna have to, and we can do the same here actually. Buckets with a big B, and let's do like this, and let's just generate that field. Bam, we have the field. So easy peasy, lemon squeezy. I don't know if that's what you say, but I said it. And then let's update. So now we're gonna consume the buckets, and we're gonna realize whoever is somewhere alongside us, right? And it's gonna be a little bit tricky, but I think people are gonna understand and appreciate it. And if somebody have not worked with spatialized fragmentation before, this is gonna be obviously committed to my open GitHub, and you're gonna probably like expand your mind a little bit, because oh my god, you can optimize so many things if you just spatialized fragment, do it whatever like this, because it's all physics engine work like this. There's no remote chance of a physics engine working fast without this technique. Interesting side notes. Anyway, so we're gonna consume all of this and make sure that we are, if we have somebody around us. And the way we do that is that we just copy over this first and foremost, because we're gonna need some data here. So first of all, we're gonna calculate where we are, again the same way, and now we actually have a point of this public static read only. That's a lot easier, so we don't have to like send these values around, right? So now we get our bucket index back again, but this time we're gonna take the buckets, variable buckets like this, and this is just because we need to make a local variable to be able to use it inside of the entities for each. I have delved into that before on other streams. I won't do it right now. And then we're gonna get, I think we can do like this. This is a little bit syntax tricky, I think. Buckets that get key array, or maybe key, I think there's something called like iterator. Maybe not. Get key value array. Get unique. There's some way of, try get first value. That's the one that we need, that we want, because no we don't want. Give me a second here. Yes, we want this. Sorry for the confusion. I'm going to explain exactly what's going on here. Let's just create a new variable here called entity, close entity. Seems like a good name. And then let's do like this, and then out variable iterator, like that. That should be, and then if, or I think if is the right term. So what we want to do here is we want to go through all of the different entities that are potentially inside of this bucket. Remember, we might have a lot of people inside of our bucket, and we need to figure out if we should avoid them. But at least we only have a few buckets to check. And right now we're checking exactly the one we are on top of right now. We're going to start with that, keep it easy. And we need to iterate through them, and they have a little bit of a specific syntax way of doing this. Let me see here, let me think for a moment. I think it's something like this: next value, out, close entity, and then ref iterator. And I think this is more or less how you do it. But you actually turn this around and do. That wasn't really intentional, actually. Anyway, do. Like that. So this means that first where are we? Okay, we are in this bucket. Let's pick out the first entity in this bucket, and let's do something with it here. And then let's use this iterator, which is more or less a hook into the potential list of all of the different entities inside of this bucket. Let's hook into it and see if there's anything left, or it's still there, and then we can just do this do loop until there's nothing left in the bucket. So first of all, we should just if close entity does not equal entity. So we don't care about avoiding ourselves, obviously. So we should check that first, and then we should check the proximity. So the way we need to get the position of the close entity to us. So close variable close position, and then get component. And I don't know if I've gone through this, so I will just briefly explain what this does. So there's like a ton of, I think I've actually used it. Yeah. But just to quickly, there's a ton of different ways to get components belonging to stuff that you are not currently iterating on. So this a close entity, we are obviously not iterating in this big for loop on. We're not on that entity right now. We found that entity inside of this bucket. So this get component that will translate. Unity will automatically translate that into the appropriate way of getting the component from this entity, considering the context of the loop. And it's specific for schedule, parallel versus run versus other versions of the for each loop. So that's why I use get component. That's a little bit of a magic trick. It generates code based on the context of the code. Anyway, we have the close position, and then we can do something where so now we want to check if we are close to it. And if people haven't done this, they should do it. We can variable dot proximity distance, and we can make data dot proximity distance or not dot multiply by itself, and this means that we can compare it to more optimized way. I'm having a little math. I'm having a little bit of a trouble explaining this while I write it. It's tricky stuff. Distance squared. So give me a second, and I will explain exactly what's happening here. 2D position, yes, because that's 2D. Oh, right. We need it like this actually. Close position 2D. And I'm being very verbose right now because it's much easier for you guys to follow if I write exactly what's going on. Dot position, because this gives back the whole transformation matrix, and we just need a position from it. So that's why I do that like that, and let's do like that, and then closer than prox distance. Distance squared. There we go. That's the way. So when you're using distance, you need to do a square root. If you're using distance squared, you don't do that square root. You won't know the exact distance, but you can have something else like the proximity distance, which is an exact distance that we will specify. And if you multiply that by itself, you will get the version of it which is itself squared, obviously. So then you can compare this square value of some underlying distance with this square value of some underlying distance. And the only thing that we care about this is like, is this smaller than this? And then we know that these are closer to each other than this individual value. We don't know what the value is because we haven't done the square root of it, but we can know that they are closer than this proximity distance. So that's an optimized way of doing it. And so now we know they are close to each other. So now we can actually do some calculation based on that. So we should probably move the other way around, but we don't know if there's a lot of people around us, and like this is where my experience with coding Boyd system not breaks down, but something close to it. I don't really know how to do this properly, but it's fun to explore, and I think people appreciate that I try to do something new. Well, I mean new for me. So I imagine that we're probably gonna want to like find the closest one and act on that. And that should probably be enough to begin with. So we need to find the closest one just. So that means that we can do this for each loop, or this thing where we should find the closest one. That's it. That's what really needs to happen. So if we do float closest distance, dist, maybe like that, and then I'm gonna show you a trick. Well, I mean, maybe not a trick, but something I do all the time. If closest distance squared variable, let's pull that out in distance squared in its individual variable, and then see if that is close to that. We can do this actually. So what's going on here is that we are just making sure that we have this distance squared in its own variable, so we can use it multiple times, and then we check, is it closer than our maximum distance? Like if it's further away than this, obviously we don't need to care about it because it's further than our proximity distance. And then let's check if it's also closer than everything else we checked. And after that we can do something like this, where we, so now if it's closer, then that's the new close one, right? Just a simple loop that finds the closest one. And we should probably test entity, maybe, no, not test entity, close, and we should make something like closest entity, and then like that, which means that we will, have access to entity itself also that is closest. I hope this is clear enough for people to understand where I'm going with it, or what's going on here. Otherwise ask. So after this we should, if this closest entity is not an empty entity reference or an empty entity, it should be the one that is closest to us and we should care about. So now we should figure out exactly in which direction this is, which is, you know, something like, let's see here, we can do like this, and we have the closest like that maybe, and then use math dot direction. Oh, direction is not something we have here, I think. Well, I mean, it's just normal, easy direction, easy algebraic expression, and then we're on our way. So we need to point, the direction of this should be from our closest unit to us, because that, so, you know, we are here and the guy is here, and if we point from him to us, then that vector would be the same distance, the same direction which we should move in to avoid him. So, and that means that we should take our position 2D minus his. That's more or less how that should be. And we can use math, normalize, and do it like that. And now we can move our character. Translation position, and we can introduce a new variable. So we can make a avoid speed. This is very simplified way of doing this, but it's still like it will get the point across. This won't be really, this probably won't look super good, but it will, as I said, get the point across. And we need the delta time, so we move in accordance to time. So we, on a slow computer, it won't move slower. So delta time, and there's something called time, which is a new time, which is inside of the system base, which we can get delta time. And since this is a local variable, we can use it straight inside of this, right? So that means that we can take position dot value, which is the actual like float 3 value underneath, and we can do something like this, where we take direction times the speed. So remember, we put in some avoid speed times the delta time. And obviously this will, direction is in 2D. This is, let me just avoid 2D, maybe that's a good way of calling it, like that. And let's convert it. Give me a few seconds here. I'm just, like I said, this is super verbose, but it doesn't really matter because it's supposed to be easy to read. I think I can do like that. No, I can't. Never mind. X, Y. That should be enough. New flow 3. 0. Like that. There we go. And then like that. So we just we are only avoiding in 2D, right? Because we are looking at a more or less flat plane, and we're converting this this avoidance to a 3D avoidance vector or 3D movement vector, because they are represented in 3D, and then, you know, they won't move in Y. So this is, you know, Y in the third dimension. So they won't go up and down to avoid. That's not what we are aiming for. Skazam, you were on top of it. I didn't see you, but yeah, good thing. I like it that you are pointing out the small stuff that I miss, even though I had the fortune to catch it myself this time. But yeah, the Y should be 0, so we don't move up and down. That's completely correct. But this should move the position properly, right? And so we can put in the values and try this out right now. It should probably work, but we will have a big bug, and that's that this bucket system will only try for one bucket. And we will, so if we are at 5, right? And we are right over here. We won't try against the guy who is right over here because we are in different buckets, and that's not obviously like it should be. So we need to put in 9 buckets, really. But we can try this and see what happens, because it's probably going to do something. Let's see here. Let's go to the laser bot, and we have our new proximity. So let's say like they are like, I don't know, maybe a meter width wide. So they can have like a proximity of 3 meters. That's quite far, but we will see it obvious. And then a void speed can be like something like 0.2, so a fifth of a meter per second to move out of the way. And that should maybe work. I'm not super convinced, but hopefully. First of all, we should just... So when we remember that when we use this set bucket, we create this multi-hash map to all the buckets, and then we tell this system, which will pick up off in the next part of the frame. We should probably, let me just fix that simulation system group. When we say give it this bucket, it will pick up the whatever comes out of this job. But if we are on frame 2, that would just overwrite the old bucket, and the old bucket will be still there. So by doing this, we make sure we dispose of the old bucket. And we can also do something like this, where we say on destroy. If the bucket is created, we destroy it, because if we never call set bucket buffer again, this old bucket will never be destroyed or disposed. So that will fix a memory leak. And let's try that. I honestly don't really know if this is gonna work super well, but let's see what happens. Oh, we have an obvious issue somewhere. So the error says buckets is not declared read-only in iJob parallel 4, which means, and this is actually a good thing that they point out, if we have a complex, I don't know if it's only native collections, but more or less native collections in practice for me. When you want to just use it, I think you should declare it like this. I'm actually not 100% sure why it does like this right now. Oh yeah, I think I have an idea, but we only want to read from it anyway. So we should, I think we have one more thing to fix. But anyway, when you only read from it, so we are just looking inside which entities is inside the buckets. We're not changing the bucket or the hash map itself. So then we can declare it as read-only, which will tell Unity that they can sort of structure the memory and the usage of a memory in a way more efficient way. Because they think, oh, this job is only going to read from it. Then this other job, which also only want to read from it, they can do this stuff in parallel, because they're just reading from it. They're not going to get confused about changing the shared data. I don't think this will make it work, actually, because I think there's another problem here, but just, this is a good start. Yeah. Job data buckets has not been assigned or constructed. Oh yeah. So that's a good thing also. We should not run this if we don't have a bucket. Or if we haven't set up this. So that means more or less that we should do something like this, is if it's created. So only if we actually got some buckets delivered with some information inside, we should use it. So that's its next thing. So is created, in this case with native collections, is more or less the same thing as saying does not equals to null. That's simplification, but sort of how you can view it. And that still doesn't work, and I'm not super surprised. So, but we will make sure that we are doing the right thing here. So the container does not support parallel writing. Oh, right. That's interesting. That's because this bucket right here, all of these different native collections from Unity. This is interesting actually. Most of them have some sort of a parallel writer version of them, which means that they are basically like, here you have a subset of the interface. So for example, the subset of this interface means that you can't get anything from it. You can only push to it. So if we make a new variable and we call it buckets, PV stands for parallel writing. I use this convention myself. And then we do the buckets dot as parallel writer. If we take a look, so this is an extension method of the native multi-hash map. If we take a look at the parallel writer, you can see it returns this substruct. And this substruct only contains these things, more or less only contains add. So the only thing you can do with this parallel writer version of it is to write to it. And that is Unity's way of like enforcing the concurrency part of it. So you can actually do it in parallel. So you can write to this bucket thing in parallel. So if you use this PV instead, it should probably work. Let's see here. Now I think it's gonna work actually. Yeah. Stuff is moving. So we can see that something is happening, and the reason why they're like lining up like this is because we are not appreciating stuff in different buckets. That's the reason. But you can, it's actually pretty interesting to see the result. They're like really lining up in like perfect, like that. And if we increase their speed, they're probably gonna do it much faster and maybe a little bit more interesting. So let's see how that looks. Yeah, so some of them are jiggling because there's no way out for them. They are inside of all of the other guys, but they just like nowhere to go. And some of them are like finding a place, and you can see right here where they are underneath the floor, which means that we haven't fixed, so they are only on top of the ground. But we can see here that we also can select them, so you can see how they actually properly work when we select them. And I think, yeah, when they are moving outside of the selection box, they actually turn off their selection indicator again. So that works like it should. Yeah, it's nice. It's not the pattern I expected them to form, but it's pretty reasonable. So now we should make it so we check all of the boxes. And that's we need to abstract our code a tiny bit to make that happen. So we should probably like make it so we have a function where we say basically like, here is our bucket that we want to try out. Here is the closest we found somebody. And here is that guy, so you can swap him out if there's somebody closer in the specified bucket. So let's make that function. Private static void find process bucket. And let's put in our buckets and have our ref float, and let's call that closest distance squared, and then have a ref entity and call that closest entity. You're taking the closest position y instead of the z line. Oh, I like it. Thank you. Yes. This one should be z, obviously. So what Skazan pointed out again, and that might be the original idea here when he said y should be 0. Oh no, y should be 0 is aiming at this thing that we don't move the characters in y, because they shouldn't avoid each other up and down. But he also pointed out that the closest position right here should be z, and also it should be z here as well, because y is irrelevant to them standing on the ground. So both of these should be the position of the original guy that we're looking at. We should only consider his y and z, or x and z, because he's on the ground. And the guy he's checking out we should only look at the x and z as well there. So this will mean this more or less. You point 107. You pointed that out also. This should probably get rid of the pattern. Apparently not. This is confusing. What did I do? I'm just gonna do a little bit of time travel again, because I want to just get back to whatever worked before. Just to make sure. Buckets, add PV. So now we should have the patterns again. Yes. Maybe it's just like some weird result of whatever we are doing, that they can't move in X or Y. Or X or Z. No, it shouldn't be. Let's see here. So we are taking the 2D position and we're checking against somebody else's 2D position. And we're seeing if we should move along some point. Oh, here as well. All of the different Y should be not there. That's why. Yeah, that's why. Hopefully they will do something properly. Yeah, so they are moving. They're doing something. I don't know if they should probably do more than this, actually. I think it's the case that our proximity distance is way bigger than the boxes. So imagine, yeah, that's it. So imagine we're inside of box 5. Let me find my cursor. Imagine we're in box 5 here, and our distance that we are trying to avoid people in is like this far. Then we obviously need to check them in this square as well. But if we only check in our absolute immediate area, probably won't work so well, because then this distance will be completely irrelevant, because everybody in your bucket is way further than that. So if we increase the bucket size to like maybe 4, and then we're gonna fix this with all of the buckets around it also. That's gonna be the last thing we do. And if we decrease the proximity distance a little bit, this is probably gonna fix it and make them like wiggle more, I think. So yeah, they're trying to do something here where I think I might have some problem here where it's only like trying out stuff in the middle, because these guys right here doesn't seem to actually care at all. But let's fix the surrounding bucket issue first, because that's probably going to be a little bit more easy to see what's going on there. So we want to process this bucket. we want to see if anything is closer inside of this bucket. So float to position. So this is our position. So if we move this whole thing inside of here, and we put inside this here, we're gonna see a few problems here. Bucket index, and I'm gonna explain exactly what's going on here. Oh, that's the wrong one. Bucket index, we need to have the uint bucket index. That looks good. That shouldn't be let's do inner closest distance, and then no, that's never mind. It's we should just not declare that. And let's have entity like that, and proximity distance should also be something we put in. So this is going to be like quite a big function call, but probably going to be worth it in the end. Position 2D, that's the position here. We can actually rename that to position 2D to be more verbose. So now we have the same function basically extracted out, and there's some more work to do. But we have an interesting thing here, and this is a learning opportunity, because this is something I think Unity is working on, because this is annoying AF actually. The thing is that this get component does not work in extracted static functions. Unity doesn't have a good way of like doing that actually, and it's quite annoying. There's a way around it, and I'm gonna show it. And that's actually the original OG way of doing it before they had this entities for each thing. But it's really annoying because it's super verbose and it's like a lot of text. So what we are looking for is something called an entity component component data from entity, and then we want to grab this and call it transforms. Let's call it like that and do it like this. So let me explain. So this works, right? So this get component, if we are inside of a scheduled parallel, this get component will be replaced with one of these in the background, or something, or more or less the same thing. I think both of these will be replaced with something completely different in the end, because it's generated code in a format that we never see. But anyway, this is more or less transformed into this type of a variable. And the way we create these variables, we can send it in, is that outside of our for each, we create something that we can call that transforms, and this is a function that inside of specifically system base and a lot of other systems, there's not a lot of different system types, but this get function is inside of most of them. So get component from entity, and then we specify our type, and then we say read only true, and that's very important because we can't change anything inside of this with this accessor, especially not certainly not inside of a scheduled parallel. Scheduled parallel are not allowed to change anything outside of the ref stuff that you put in, right? Everything else will be everything else that we want to change, we need to do with entity command buffers like we have used before. But anyway, so by doing this, we get the sort of accessor to the local to world components, and we can then call this process bucket. So we're gonna basically swap out all of this. So let's do like that, keep it, and then we're gonna put in everything. So buckets, and then bucket index, and then we have our entity, and then we have our position 2D, and then we have our proximity distance, and then we have our ref closest distance. So this is something we need to do like this, pull this variable out and then put it in here. Then we have a closest distance, closest entity. Oops, like that, ref, blah, blah, blah. And now we can pull in transforms. So this is how you do that. You know, we're gonna call this 9 times. We might as well do a function out of it. But then the thing the bullet we need to bite is we need to do this. And you can see how this is annoying to have to do this transfer, because otherwise we could just use get component, because that will do exactly the same thing. My whiskey is almost done. So we should do this. Should technically not make any difference. That's the point of this code. And then we're gonna call this function 9 times over. But let's just check and see if anything breaks. Yeah, something breaks, and that's because this read only. We declared our bucket, so we specified unity. We're not gonna change anything inside of this bucket list or this big thing, but we need to say the same thing about this one, I think. I don't know why it's so goddamn verbose, but I think this is the way we should do it, if I remember correctly. Yeah. So now we have the same thing, and we know we have the problem with only some of the units moving. I don't know why it's not picking these up. We're gonna figure that out soon. Oh, I just realized why. There we have another y position, so that's why it only used like a small section. Like if we take a look from this perspective up here, it only like used this part because it was trying to like calculate it based on like the height. This was the actual volume it was calculating them based on, because we used the y value again. So now we're probably gonna get more proper result here. Let's see what happens. There we go. We got a grid. Well, we still have some work to do, but this is the result I was expecting. So now they're like, everybody's like standing in the middle of the buckets. So they probably, a lot of people duplicated in the same bucket, or not duplicated, but there's a lot of them on top of each other in one bucket. Or yeah, something like that. So now if we consider all of the buckets around us, voila. And the way we do that is, you know, we need to try once here, then once here, and up and down, and then diagonally. So let's see if we can calculate these bucket values. So, and I'm going to be once again super duper explicit about this. Let me think for a few seconds, because there's this one thing that is really strange here and you need to consider. Let me just think. Yeah, that's a much better way of doing it. So the problem we have right now is that if we are, so let me back out so we get more visibility here. So if we are here, if we are in bucket 6, and we try to check out this bucket, and let's assume that there's only 9 buckets in the whole system. We are on the edge right now. What should this entail? It's like undefined. It should obviously not be this, or anything else. So it should basically be like, that's outside of the range, let's not do it. The way I would do this in production is that either I would have some if statement that like filters out these buckets that like doesn't exist, or I will just make sure that the bucket grid is just like one click bigger than the actual map that we inhabit. And we're gonna do the latter because it's easier, and so we don't need to write a bunch of if statement for this. So we're just gonna make sure that our grid is big enough that we never get close to the edge. But anyway, one quite easy way of, let's see here, let's think for a moment. I think that the best way of doing this is, so let's see here. So we have the first bucket, right? And then we can just call, this is set up right now, so we can call this once again, and we can just, and these two will be swapped out for a closer entity if there's something closer in the new bucket index right here. So we can just call them all over and over again with a new index. So let's see, let's do like this, plus plus. So we have the one to our right, and then do something else where we do minus, let's do right, which is equals to plus 1. So let's name them. It's much easier to handle them. Left minus 1, like that. I think you guys are following. It's not that tricky. And we need an item this. So 4, 5, 6, 7, 8, 9, and then let's take up, down, left up, left down, right up, right down. So that should be all of the directions, and let's just swap this out so we push in the correct index here everywhere. And this can obviously be a lot simplified in the amount of code I write, but this is, you know, as I said, verbose and nice. So how much do we go up to get to the next point here? So we have the next one here up. That should be the width, the space width. So that means that we should take this space map size. So let's use bucket index plus map size dot x. So that means that we will like, oh, this is actually once down. Maybe we should, yeah, that's let's fix that. Minus should this be, and then we should have it, that should be plus, yeah. Let's see what's going on here. Right. Let's see if we can do it like that and get away with it easier. It's just a type thing going on here. C# is so goddamn typed, is ridiculous sometimes, but I guess it's a good thing to have it really hard typed. So we're just gonna change these two. Yeah, that's enough. Bucket uint. Oh, it's the wrong way around actually. This should be just converted to int. So C# is happy about our types. So it's just like uint, int. It's not really necessary to care about which one it is, but it's more explicit that, you know, you can't have a negative index. That doesn't make any sense. Anyway, let's go back here, and we can see now that like up is, so we take this, so imagine if map size is 3 times 3 buckets big, like this one, then we will have the 5 minus 3, which is, you know, 2, which will end up here above us. That's it. So up, down is these two, and then we have left up, which is left up should probably be the up minus 1, because then we are up 1 and then minus 1, and we get to the upper left. So, and all of these are, it's annoying to write these down because, you know, you easily get them wrong, but it has to be done. So down left should be down 1 then -1 again. So down and then -1, and then we have up right, which should be up +1, and then up down, which should be up -1. So now this might actually work. I'm not 100% sure, but you know, maybe. Let's do this. I think this will benefit the readability of the system quite a bit, because then we can see the patterns in the different things here. And do something like that so we can have a better overview. Yeah, right, left, up, down, left, up, right, down, and then we have all of this, which is, yeah. Oh yeah, there we go. So we actually had a problem here. That should be down -1. That's why I put everything in, because it's easier to see. Left up is up, left down is down, and right up is up, right down is down. Yeah, super boring to listen to this. Let's try it. Let's try it. Yeah, you can see here. So the difference here right now is that you can see how they're actually getting spaced out pretty properly. They are expanding way outside the grid, so they are considering new grids all the time. No, but new, they are expanding outside the original bucket. And like, this is obviously, the problem is here, like these guys that is inside of here, they're sort of stuck. Because when they push on somebody, they need to push on somebody, so they push on the next one, and then which will result in somebody on the edge moving out, giving more space to everybody. And that needs to happen to be able to space everybody out properly. But it's really hard to... So the main thing here is that we will not... You know, we won't just throw a bunch of units on the ground on random positions and then expect them to position themselves properly. That's not how this will work. They will, you know, be created on a position that is from the beginning valid, well, where they are not too close to somebody else. And if these 1,000 guys would position themselves, would be created on an original valid point where they're not too close to anybody else, and then if we will like move them, they will stay properly spaced. It's just that this start point is hard for them to handle. Yeah, let's see, to bring it home. Let's see what this takes processing wise. Let's just make sure that we have names for all of this stuff. So name, this is, you know, a way to name our jobs so we can see them in the profiler. So proximity, proximity, like that. And let's grab another one, and let's prep buckets. Yeah, so I'm just using capital letters just to it's easier. There's so much stuff going on in the profiler, so it's a lot easier to see it like this. Anyway, let's see how it looks. I don't think this will be much at all, actually. So if we take a random point here, move over to this stuff, and let's scroll into, so the prep stuff takes a total of 0.2 milliseconds. I think it's quite fair. There's probably some optimization we can do there if we wanted to, but you know, it's not a big deal with 0.2 milliseconds for all of the 1,000 ones. And then we have the selection, still only takes, yeah, now when we have a lot less, the test from the other stream was with 10,000, so 10 times, but with only 1,000 we have 0.075 milliseconds, and then we have eventually this proximity thing, which is taking a total of 2 milliseconds. So that's actually quite a bit, but still, like, this is 1,000 guys checking exactly where they have the closest people, and there's probably something I can do to make this faster, but it's not really necessary right now. We're not aiming for to super optimize this. We were aiming for showing that without knowing like assembly or micro optimization on a deep level, you can actually get super good performance out of this just by writing reasonable code in the DOTS constraints. So let's consider. I think I'm gonna end this stream pretty soon, because the next part of this will be, you know, like saying go here. Maybe we can code something that actually makes them go somewhere right now. Let's think about this for a second. So if we say if they have a target, so because if they have a target, we can integrate that target direction with this avoid direction. We can basically add them together, and they will probably do some sort of a thing to make that happen. So let's detect a right click and make them move there. All of the selected ones. I think we can do this in 15 minutes. Should be possible. So if we take the selection UI, and the dragging right now is, you know, detected by mouse 0. So if we have, when we are not dragging, if mouse 1, I think, I don't remember which one. Let's just check that out to begin with. Log. I'm just trying to figure out which one is the right click, because I forget all the time. So let's see here. If so I got the exclamation mark by pressing the right button. So get mouse button down, and let's have another point position here, which we can name I don't know. Oh, right. So let's do something like this. What should we name this position? Right click. I don't know. It's hard to know what the hell this is supposed to be. Input dot mouse position, and I think this is in where it's XY, I think, and we need to convert this to screen in world position, right? Am I thinking about this right? It's isn't that like, now we can use the camera, mouse position. Now we can use the camera because this is just done once, so it's not a big deal to do it with the camera help function, because we don't need to do the transformation by ourselves. So mouse camera get world position screen to world point. That's where we're going for. So, and then we put in the selection dot right click. Stupid name, but I don't know what to tell you. Yeah, that should be it. So now we should get the world position. Variable right click click world plus like that. We actually need this value inside of our other thing. And this is, obviously you need to structure this type of code in way more smarter way if you're gonna do something big. But it's not a big deal here because we're just making small stuff. So we can do it like this, and obviously camera and selection is not gonna exist here. So let's just pull them in. So we have them. Selection, we need selection as well, which is this one. Public, like that. And then we need to, oops, my bad. I should probably hype this final thing more because I think it's gonna look quite cool. And there's in the rate that's a point on the near plane of the camera. Oh, you're right, Skalsam. I hope you continue watching all of the future ones because you catch my stupid errors. That's obviously. So what Skalsam is pointing out is that this is the screen point. So this is like. This is, if I'm not mistaken, this is like the point of the mouse position on like this plane right here, I believe, which is not at all what we're looking for. We're looking at we want to like raycast into the screen as into the world and see wherever we hit. That's the point. So let's see here if we can make that happen. And we already do something like aren't we raycasting somewhere? Yeah, we're raycasting in the spawn thing, I think. So we can just grab that code to make life easy. Yeah. We are raycasting somewhere here. Build physics, collision world, raycasting, start end. Yeah. Which is, exactly where we are going, I think. No, not really. Well, close enough. We can just steal this piece of code, and then we can. It's hard to know where you're supposed to put this code because I don't really know the overarching structure that's gonna emerge from this, but it's not a big deal, so let's just put it somewhere like that. I'm just being lazy and putting in this stuff wherever it feels easy, like that. We should include that one, and we should create a new field from that, and that should be there. And then we have our physics, which we should put in, and then we have our now we have this raycast screen point to ray. Yeah, right click ray. That should be, and this is in the old ray, so this won't fit into the new Unity physics. So we need to do like the origin until the end, which is not actually present. So get point like that. That should be enough. This means basically we start wherever the ray says, like the camera is like right at the start of the camera, and then we point it in direction of the ray 1,000 units forward. So we're not gonna miss the ground if we use this one. And then we need the ground filter, and let's just be quick about this default filter and make it collide with everything, because we want to see result now when time is almost running out. And then we're gonna have the hit position, so let's name that like variable let's see here, how do we do this? variable right click world pos. That's not float 3, like that maybe. New float 3, and let's put that into this one. Hit info. So we essentially just find wherever the ray hits the ground, and then we can use this. And we should actually detect if we actually have a ground hit. We can do like this actually. We don't need to make this into an if statement. There's no point in it right now. Because something like that. That should be enough. Because if we don't hit anything, the hit info that is returned is just 0, 0, 0, and then we will know with the ground hit boolean that this value is invalid and we can't use it. So this is just find the ground. That's more or less it. So now we have a world position that we're gonna walk towards. So let's do it like this. Let's calculate where we should walk and then distance ourselves. So the distance, the void thing is last in the system and has the most influence on the final position. So let's if ground hit, then do something like this. And instead of using the closest 2D position, we can use world position, and then we don't need to use this 2D position completely. So now we basically doing the exact same thing. Target. The only difference is that we are doing it in full 3D with an actual point on the ground that we are raycasting towards. So we have a direction, and we should probably use that direction in its full 3D glory, like that. So we get our raycast position on the ground, and we see wherever, whichever direction that is, and then we move towards that direction, and we should do target speed like that. So we have a new target, we have new speed that we can use, which lets us have a more, so by doing like they move towards the target with a specific speed, and then after that they make sure that they move away from everybody else with a specific speed. So by doing this order and having different speed available, we can sort of semi prioritize going towards the target or avoiding nearby units. And this might actually be it. Let's see. I'm not too confident in this because it's very fast programmed. So let's make it like maybe 0.5. So we are more concerned with avoiding everybody else, right? There we go. So now they are moving towards this point right here because I pressed there, and we are just doing it with everybody right now because it's easier. And if I right click on the right side, everybody moving right there. So that works. And we can actually do something like this where we increase this to 2, so they're moving way faster. And then we can do, so now we have, since we have the unit data, we can actually take the unit data selected and making sure that we only try to push the ones we have selected towards the goal. This is actually coming together pretty good. This is a good ending on this node. And let's reduce the amount of people we spawn just because it's easier to see what's going on. So now everybody's, you know, spaced out, properly spaced. So if we just select all of these guys, we can move them. And you can see they avoid each other. Well, not entirely, obviously. So the movement which they avoid each other with are way less forceful than the movement they try to move towards. So if I still want them to move pretty fast. So 2, but then we take avoid speed to like 3, and like there's better ways to do this type of prioritization between moving towards the goal and actually keeping your distance. But right now this is a pretty good way of doing it. So now we have the result I was sort of expecting, that they are trying their best to do this stuff, but they're like jiggling to make it happen. But you know, if we let them move a little bit, they eventually space out a little bit better. Yeah, I don't know if it's much for the world to see, but I think it's pretty cool. And so one of the things to realize here is that when I select them, they instantly start to move somewhere, and that's more or less because we don't really care if we actually pressed on right click or not. We're still trying to use some sort of position. I think that's the problem anyway. Anyway, I think we can leave it here, and I'm gonna have to process where we're going and see what would be the best approach to continuing this system. But as we can see, we have something where we can actually move our guys in a semi good looking way. And by increasing there's so much you can adjust with this. You can probably get them to like do much more of the school of fish type of movements. So yeah, next time I will make this better so they don't wobble around, and I will make sure, because yeah, this works actually, and now I make sure all of these like grabbing things work as you expect them to do. Yeah, I think that's, and then I think another thing that we're gonna focus on the next stream is that, so if we double click one of these, I want it to select everybody with the same type, and we can do some fancy DOTS code to make that happen, and that's quite interesting. Yeah, how about that? It works. So next time, specific type selection and then better movement, and maybe we can do some shooting against an enemy soon. So that's it. Thanks for watching. I hope some people learned something. I at least learned something, or confirmed a lot of stuff that I thought about. So good thing. Good night, everybody. See you next time.